Hey guys, here's my semi-quick explanation of type notation in Roblox Studio. So just while I was editing, I noticed that the recording did not pick up any of the IntelliSense at all. So sorry about that. I do point to it a few times in the video, so you're kind of just gonna have to trust me there. So what type notation in Roblox Studio is supposed to do is effectively verify that the variable we're creating is going to be of a certain value. So when we create a variable in Lua, we can just say local this variable equal to be a string. And the interpreter will understand that this is a string. We have all the methods of string objects in Lua right here. But this often comes at the sacrifice of some level of readability. Especially in large projects, large code bases, it's often better to have the type annotation there so that people who go and read your code, or if you come back to your code later on, you can understand that this variable is supposed to be of a certain type. So if this is always going to be a string, we can just put a colon here and call it a string. And this enforces it throughout the code, especially if at the start of the code we add strict. This code assist, can you go away, please? So this enforces this variable always being a string. If we try and go this variable equals 0, that will actually error. It will say type number could not be converted to a string. Or if we wanted to set this variable to equal true, that's also going to error out because true cannot be converted into a string. We would have to do that ourselves somehow, probably using toString. What can we actually put in this type is pretty much anything. So here we can So we can say that this variable is always going to be equal to nil. I'm not exactly sure why you would do that, but you can say that it's going to be equal to a string, a number, boolean, etc. You can also, as you saw there with the autocomplete, you can set it to be things like instance or GUI base. So say we don't have a direct reference to a particular frame, we can still set this variable to be equal. There we go, we've got visible was false. Probably want to set that to nil just because we need to instantiate that properly. That won't work because obviously you can't set a nil object, set a property of it, but that's just an example. You can actually also add enums. So if we have material equals enum.material dot, I don't know, rock, we can specify that that's always going to be an enum.material. And so material enum.material.neon. That'll work properly. And we can also get data about enum. If we try and set that to like rock, that's going to error out. You can actually also create like a optional type. So if you have this string, or I'm actually going to call it this maybe string. I know, a very creative name. String. This may exist. And we can actually also add a question mark here, just so that anyone reading this code and the interpreter understands that the string might not exist. It will likely be a string, but it could also equal nil. There's also literal types. So you can say that this maybe string is going to equal, this is a literal string. I don't know why I capitalized string there. I'm just gonna remove that. So this must equal the exact same string. So if I try and set that, that's not going to work. It's going to be like type empty string could not be converted into this as a little string. We have to have the exact same string here. I'm not exactly sure what the purpose of that would be. I can't really think of something. Do with it what you will. You can also have this with like boolean, so this false equals false. Try and set it to true. It's not gonna work. Set it to false. It'll work fine. I guess you could use this in some sort of like verification. You want it to throw an error if it's not equal to true. I guess that could work. I've never tried it. So this is all when you're instantiating a variable, but if you already have an existing variable, so equals if we already have a variable, set it to be a string. You could also say another variable equals this variable. So I guess that's mostly just oh, it's never initialized. Great. So this is if you have an already existing variable and you want to assert, that's what it's called, assertion, it to be a different type of variable. So this is how we do type checking within variables inside of the, I guess, like main scope of a script. But what about when we have functions? So if we have a function that adds two numbers, turn a plus b. So if we have a function that's a plus b, we can actually enforce the type checking on here, which in a very complicated function could help with people reading what things are doing, especially if you have quite vague variable statements like here, or variable names like a and b, or if you have variable names that don't quite show what type of variable that's going to be. You can actually enforce that to be a number within the arguments. So we know now that this is going to be a plus b, and the type checker knows this. And we can also, after the parentheses, we can show what variable this is going to be. It's not going to be a string, thank you. Or if we're going to return out multiple values, so say if we just want like a verification that it worked, we can put this in another set of parentheses and say number, comma, boolean. And so we know now that that's going to spit out a number as its first return and a boolean as its second. So say we could have an array of players in game, or currently existing players. And we're going to chuck a curly bracket there. Well, we go back just after the variable name, put a colon in, curly bracket, and we're going to say that that is going to be an array of objects of type player. So that means that the type checker knows that when we go into currently existing players and we specify an index, this is actually all going to be a player object. We can say that we can grab their user ID. Yeah, I guess it's just a lot more readable. Anyone going in, editing the code will know that that's going to be a player and will get it in their autocomplete. And I guess that's the main point of type checking, is it's really just like a more organized, cleaner way of writing your code. So this can actually use dictionaries as well. Yeah, so we could have a message, chuck a colon in, curly brackets, and we can say that that message is going to have contents, which is going to be a string. We can have its sender, which is going to be a player. We can have the profile picture, which is going to be a string. We can have maybe an attachment, not a Roblox attachment. Attachment is also going to be a string. Probably both of them are going to be URLs, and this is probably going to freak out because this all needs to have the same data within it. So yeah, we actually need to say that that has contents. Hello everyone. Sender equals players.hurricane Xerox. Profile picture equals RBX acid ID 0. and attachment equals nil. And we could actually use that question mark there. As you can see, that got rid of the error message there, because sometimes a player might not have an attachment in their message, so we just put that question mark there. And this also works if we have indexes that are like, say, the name of an object and then data about it. We could just have a table and say that its indexes are always going to be of type string, and their value is always going to be, say, an empty table. We're just going to chuck, like, I don't know, that could be JSON data in there. And that's always going to have indexes of type string with content that are tables of type string. But what if we actually want to reuse these kind of things? Say if we create a new message and we want to just reuse that as a message data object that we can just call when we use the colon. We can actually do that by getting type message equals this, and create a curly bracket and put in this data. And so now we can actually reuse this. And so that message equals this, and then we can just say that that is of type message. Just say this message. And so now that can actually be reused, because we could say now another message equals, say, like, hey guys. And so now the content of this can actually, say if we have this saved into some sort of cache, we can say another message dot contents, and now we've got all the autofill data about contents. We can have profile picture. Say we could save all these messages into like some sort of big data table, and then GUI can access that, load it all in on the screen using all this saved information that we have. And this is universal, so as long as we supply this, any script in the game is going to be able to access this and know that this message is going to have these variables. We can actually do the same with functions. So say we have type arithmetic, I cannot spell today, arithmetic operation equals, and this is our notation for functions. So say we could have two inputs, number, outputs a number. Great. So we could say have a data table, arithmetic operations, and we say that this is string. So we're going to have different arithmetic operations that are indexed by their name, and then each of them are going to be an arithmetic operation. So now the code knows that whenever we index an arithmetic operation, it will show us that it's going to be a number, and then output a number. Even though that doesn't exist, the code still knows that that's going to be a thing. And as you could see, type checking in action, arithmetic operations index it with a number, it freaks out because I said that they should be indexed with a string. So yeah, I've just created all the arithmetic functions. We need the 4 basic operations. So now we can actually call this and say arithmetic operations, say we want sub and 1 and 2. You can actually print that off and go -1. Great. And so everywhere in the code base, we will know that when we call a function from arithmetic from arithmetic operations, we will have 2 inputs of type number, and we'll return a number. There's also another thing when we're creating this arithmetic operations called Variadics, which is where we might want an unknown amount of arguments. Say if we're creating a sum function, and we don't know how much numbers a user will put into this sum. So we can actually put 3 dots, and the type checker knows that this will be multiple variables. So we can say that that is variadic of type number. And so when we create our sum function, we say that this is an arithmetic operation, equals function, ... And what we'll do here is go for number in, and then squirrely brackets, and then the variadics. And that will loop through all of the entered variadics here, so we can go like sum equals 0, number, sum plus equals number, return sum. So you can actually specify multiple different types. So say if we have a function that's called string or number, we can say that that's going to be equal to, say, like 0. And we can say that it will be string, or, because that will freak out if we say it's just going to be equal to a string. So we can actually put this line here and say that it's going to be string or number, and then that calms it down. String or number can also be equal to like this string, but string or number cannot be equal to a boolean. That will freak out. If we were to have multiple different, so like say message or player, and we had 2 different data types, so like type message equals, and then content string, type player equals this, user ID number, and say we wanted that to equal, I accidentally said plater, my bad, and we could have message or player be equal to either one of these, but nothing else. If we wanted to say that it is equal to message, but we have a user ID and call that 0, that will freak out because it's not compatible with message. So we can chuck in player here, stops worrying contents, and that should be hello, and that all works fine. And this still actually works where if we have the contents and user ID in one thing, the type checker won't actually freak out about that. If you actually have one of these as an argument using the intersection operator, this won't actually display anything when we try and get information out of this. There won't be anything in the autofill. We actually have to use the ampersand to get data out of that, and we know that this is going to be an intersection. So this as a union, so this actually merges together these 2 different data types, and we know that this data type is going to have both of these contents. I'm not sure how this would work. It's something that you would just kind of know that this is going to be how you have to do it. I can't really think of anything on the spot where this would be useful. You can also create something called generic types, where say we could have something like say top 10 objects and have it equal to a table. We could say type top 10 objects equals a table where we have a number, and then, oh, we might actually not know what type of object is going to be in this top 10 objects table. It's designed to be quite vague. So what we could actually do is chuck in these angled brackets and say this is going to be say an object of type T, and we can actually now say, oh, this might be of object type. So this is now a variable. Well, I'm not sure variable is the right word here, but we always know that this is going to be of type T. So now if we say top 10 objects and say that's top 10 objects, and we're going to say that this is always going to be an instance. And so now we can have like 1 equals game.workspace.baseplay, 2 equals game.workspace.spawn location. Great, okay. And now if we go in here and reference something, we are always going to know that that's going to be a instance. Even if we don't specify these, if I go and say, oh, we're going to try and get instance 4, we still know that that's an instance, even though it technically doesn't exist. You can actually also have 2 variables here. You can have as many as you want, really. You can have, I don't know, k. You're going to chuck that in there, k. And now we say, oh, actually, wait, no, this isn't right. It needs to have 2 variables, number, instance. And so now this is all fine. It's not going to freak out. If we try and set this to be equal to string, I'm not entirely sure why that's not freaking out. It should, but I think you get the idea. So this is all great and all when we can have create types like this and say, like, I don't know, player data model equals this, and so we could have like cache number rebirths number. I did not spell that right. Again, my spelling is terrible today. I was not supposed to hit insert. And then we could have like owned pets equals that, and it's a oops, my bad, was not supposed to put equal there. And we could have another type that's type pet equals that, and it's like value, number, rarity, also a number, name, string, or like ID string. And then we can also say that it's a table of type pet, and that can actually be all of this when we create a so like game.players, player edit connect function, this player, and then we could say like local player database equals this. Should probably have that after our type. Oops. And then it's a table of type ID. Oh wait, my bad. That's not how we do that. Have that, and say they're brought in with number. That's player data model, and there we go. We've got this whole like database system, and we can say that a local bit or player database is player user ID equals that. And we just say that cache equals 0, rebirths equals 0, own pets equals an empty table. Forgot my commas, my bad. And yeah, and we could just have like add player database to data store. And whenever the player joins, we can just have the game load all of this in from the data store. And there you go. You've got like a really basic data store save system for some sort of like pet simulator. Great. But all of this this in particular can't actually be accessed outside of other scripts. We want to go and create a script and say like, okay, this pet, and this could be like the pet handler. This pet equals that, and then look at that, no pets. Very sad. What we could actually do is have a module script of types, and you can organize this however you want. But we can actually take these, put them in our types, just quickly grab type module, course require script parent. Oh, whoa, don't know what I'm doing. Dot parent dot types. Grab this real quick. Chuck that in here as well. And what we can actually do is add export to the start of these. Add export here too. Great, so we've got all this, and now what we can actually do is say type module dot player data model. So now we've got this type that we've just grabbed from this module and can access anywhere else in the game. Say this one here as well, type module dot pet. Amazing. And we should probably set that to strict so it yells at us. There we go. And say why is that not working? Oh yeah, I changed it. Value equals 100,000 coins. ID equals bleh. And what was our other one? Can actually, if we hover over it, type module dot pet, missing field rarity. So rarity equals like 5. And why is that not working? Property ID is not compatible. What did we make that? That was a string. Okay. So this is now a fully valid pet. This is a fully valid data model. Yeah. So that all works together. That's typed scripting in Roblox Studio. So I hope you have a wonderful day. And make sure to subscribe and like if you liked this. See you in another one.